Space is often described as a void, a place of nothingness, an endless reach of silence. But silence is not safety. In the deep dark, far from the light of familiar suns, there are ghosts, corpses of stars that refuse to rest, objects so violent, so contrary to the laws of our world, that they seem like errors in the fabric of reality. Among these, one stands alone, small, invisible to the naked eye, but capable of dismantling the very atoms of your body from 1,000 kilometers away. This is the Magnetar. To understand the ghost, you must understand the death that created it. When a star much larger than our sun reaches the end of its life, it does not go quietly. It dies in a supernova, a cataclysmic explosion that outshines entire galaxies. But the explosion is only the beginning. While the outer layers are blasted into space, the core of the star collapses inward. Gravity wins the war. In a fraction of a second, a mass twice that of our sun is crushed into a sphere only 20 kilometers wide, the size of a city. The result is a neutron star, a city-sized corpse. The density of this object is beyond human comprehension. The atoms themselves have been crushed. Electrons have been forced into protons, creating a solid ball of neutrons. It is the densest solid matter in the known universe. Take a single teaspoon of this star's material. On Earth, that tiny amount would weigh 1 billion tons. It is as heavy as a mountain range, condensed into a single drop. If you were to place it on a table, it would not sit there. It would pass through the table, through the floor, and through the crust of the Earth like a hot needle through silk. It would not stop until it reached the gravitational center of our world. But some of these corpses carry a darker legacy. Most neutron stars spin and pulse, sending beams of light across the void like cosmic lighthouses. But a rare few, perhaps 1 in 10, possess a magnetic field so intense it rewrites the laws of physics. These are the magnetars. Every magnet has a field. The Earth has one. It guides our compasses and protects our atmosphere. It is weak but stable. A common refrigerator magnet is stronger, but still harmless. An MRI machine in a hospital is stronger still, capable of pulling metal objects across a room. A magnetar is different. Its magnetic field is 1 quadrillion times stronger than the Earth's. It is a force so powerful it creates a region of space where chemistry itself becomes impossible. Consider the distance. If a magnetar were positioned halfway between the Earth and the Moon, it would not need to touch us to destroy us. It would not need to fire a single beam of radiation. Its magnetic field would instantly reach across the 200,000 kilometers of vacuum. It would pull the data from every credit card on the planet. It would dismantle every computer, every hard drive. Every digital memory of our civilization would be erased in a heartbeat. We would be left in a world of useless plastic and silent silicon. But the magnetar is not just a passive threat, it is a ticking time bomb. The surface of a magnetar is not liquid. It is a solid, crystalline crust made of ultra-dense iron. It is 10 billion times stronger than steel. But even this crust cannot withstand the pressure of the magnetic field. The field pulls on the star's surface, twisting it, building up a tension that must eventually break. We call this a starquake. When the crust snaps, it releases a burst of gamma radiation so intense it defies description. On December 27, 2004, a starquake occurred on a magnetar named SGR 1806-20. It was 50,000 light-years away, halfway across the galaxy. In 1/10 of a second, the starquake released more energy than our sun has produced in the last 100,000 years. The blast was so powerful that even from 50,000 light-years away, it physically altered the Earth's upper atmosphere. It blinded satellite sensors. It compressed the Earth's magnetic field. A ghost, screaming from across the dark, momentarily touching our world. Now, imagine an encounter. You are drifting through the void, protected by the thin hull of a spacecraft. The star is ahead of you. It does not look like a monster. It is a tiny white-blue point of light, surrounded by a faint purple haze. It is beautiful. You are moving toward it. There is no heat, no fire, no sound. Just the cold electric glow of the magnetosphere. As you reach the 1,000 kilometer mark, you feel nothing. But your biology has already failed. The magnetic field is now strong enough to overcome the electromagnetic forces that hold your atoms together. In our world, atoms are roughly spherical, but here, under the pull of the magnetar, they are being stretched. Your atoms are turning into long, thin needles. The chemical bonds that make your DNA, your blood, and your brain are being pulled apart. The water in your cells can no longer exist as a liquid. The iron in your blood is being gripped by a force stronger than any muscle. Chemistry is no longer possible. Biochemistry is a memory. You do not bleed. You do not burn. You simply dissolve. You become a cloud of elongated particles, a stream of needles flowing along the magnetic field lines of the star. You are incorporated into the ghost. This is the reality of the magnetar, a city-sized graveyard that dominates its surroundings with an invisible iron grip. Magnetars are rare. Their power is so great that they burn out quickly. They live for only 10,000 years before their magnetic field fades and the star becomes a standard, quiet pulsar. In the timeline of the universe, they are a flicker, a brief, violent spark. But while they live, they are the undisputed masters of matter. They are silent killers, small, cold, and capable of rewriting the rules of the universe. We live in a world of weak magnets and stable atoms. We are lucky, for in the deep dark, there are objects that do not care for the laws of biology. If a star can dissolve your atoms from 1,000 kilometers away, what happens when you enter a place where there are no stars at all? A place where the very concept of something disappears? Click here to enter the Bodas Void. And as always, don't forget to like and subscribe. See you next time.